On behalf of Google Cloud, I welcome all of you. It's truly an honor and a privilege to come here and share some of the work we have been doing in the industry. I hope to cover parts of that in my presentation. One thing I would like to begin with, you all know Google as a consumer company, and rightfully so. Google Cloud is an enterprise offering which is to enable our enterprises and organizations with a mission to enable organizations to help organize and make the information accessible and useful. This is actually modeled after Google's own mission, but the difference here is Google Cloud's mission is more for the enterprises. When we say make it accessible, Sharon talked about APIs. So think of APIs as a way to have the data move, and it's not just constrained in the four walls of a hospital, but the data belongs to the patients. When we say secure, any conversation in healthcare, security is paramount. And when I say useful, that means AI and machine learning to apply best-in-class technology to make that data useful. So throughout my presentation, I will weave these three themes in. This is the mission that inspires us, and hopefully I'll share more case studies there. But before I begin, how many folks here think we can do this query today? Let's say I'm looking for all the females aged 45 to 60 with a specific biomarker, BRCA1 and BRCA2, who haven't had a mammogram and haven't seen a doctor, and I want to make an outreach for them to come to the clinic and get the mammogram done. How many folks think, there's no AI, machine learning here, it's analytics. How many folks think we can do this today? Show of hands, like, this is very reflective. Doing this task is very difficult. Why? Because your health information is in your EHR systems, electronic medical records. Your images like mammogram, EKGs, ECGs, all that are in specialized software packs. Your genomics information, not everyone is sequenced today, but if it were to be true, it will be another biobank. And then your membership, your insurance information as to when was your last appointment is in a completely different system. And to combine all that to run this query, that's where we believe the future needs to be. And Google Cloud can help with that because the trick here is to get all this different data which is siloed from a patient perspective and bring it all together in a common way so that you can run a query like that. But when I talk to, in my global role, a lot of providers, payers, insurance companies, they're asking a lot more questions, not just this simple query. They're asking, the one example that I shared, how do I ingest the data from cross-modality? But they're asking about patient experience. We all talk about patient being in the center. What does that even mean? And provider experience. The conversation about patient experience isn't complete if we don't take care of our physicians who have to deal with these broken systems and interact with multiple different portals when a patient goes to a GP versus when they go to the hospital or a specialty clinic, they don't have the view across the data. That's what we call the physician burnout. And then we talk about decision making. Healthcare industry, on top of that, there are multiple forces that are shaping the healthcare landscape. Rise of patient consumerism. We want the similar experience as we expect from other applications in our lives, be it using Google Maps to come to our destination, be it taking Uber. Similar experience is where patients are looking for ease. If I want to book a same-day appointment, they're looking for those engaging, connected experiences. When we look into the hospital system, they're running on very tight margins. And their margins are further shrinking. It's single digit. So financial viability becomes a challenge when you're bringing new innovation. It needs to speak to how are you saving the money? Is it solving a burning pain point? Is it really going to help with the shrinking margin? Workforce burnout? Over 42%, this is a US number, physicians feel burnt out because they're having to deal with the EHRs and then being able to really document for the billing purposes. That's the purpose of the EHR. In their view, that has reduced their work to a lot of documentation. And shift from volume to value. A lot of focus was fee for service. You went to a doctor and they got paid anyways because it's a fee for service. And now a lot of industry momentum is towards the value. It's not just that you went to the doctor, what was your outcome? So all these different forces are coming together, which is causing what we see, a digital health transformation in the industry. Why now? 3 big items that I've listed here: consumer expectations, regulations, and cost trend. This is actually true for US. 20% of our GDP is spent on healthcare, and yet not the best outcomes. The healthcare transformation journey, how many folks here are from the provider organizations or know the clinical record systems? Not many, but I'll walk through what yesterday was. I grew up in India. I'm very used to handwritten notes from my physician. How many folks here remember that? So our industry has done amazing stuff in the past 10 years. Most of those records are now digitized. Our health story has changed from hand-scribbled notes to a digital digest with volumes yet to come, and EMRs have made it possible. Today, that information is there in the EHR, but then it needs to be liquidated, and that's where the application programming interfaces or APIs come in. But tomorrow is really, can we make these experiences more powerful by the infusion of AI and machine learning? So this is our roadmap most of our customers are taking. In US, the regulation which caused the most of the digitization, so now 90% of the hospitals have this digitized record, which is amazing, right? To have all your history digital, available for many, many years. And this was done by, again, a regulation. 32 billion plus were spent. Money was allocated to the provider system, and they built that layer. Now it's incumbent upon us to really build on that digitization that has occurred to take the journey as I laid down here. Why the journey is important when we're looking into a patient and patient centricity and putting the patient in the center, there's a strong belief that creating the right intervention at the right time and connecting the dots from the patients will yield to better outcomes, better value, and lower costs. And that means, as I shared with you, not just combining your medical records, your genomics information, your imaging information, where you live, your lifestyle. All that has a great implication of how healthy you're going to be. If you remember one slide from this, old will not get you the new. It's a brand new paradigm. These are new data sets that are coming in. These systems that have been built so far with the digitization have been here for many decades. And they were not meant to be, when you got sick, you went into the hospital. And now when you're talking about remote care, telehealth, remote monitoring, your data needs to be mobile. And that requires a very different level of thinking. So how do you go about doing that, right? When you say old will not get you the new, I believe there are 3 pillars to democratize innovation, to build the next generation experiences. The very first one on the is democratizing technology foundation, the new infrastructure that is there pre-built, and I'll share what that is, machine learning, democratizing that, and then interoperability, meaning a patient has access to their data and making it available to them. Now let me double down on what democratization of infrastructure means. As you know, Google, as a consumer company, we have been working very hard for the past 20 years to be the most loved consumer company to add value to our consumers. Over 8 products with 1 billion users each, and we use that on a daily basis. While it is impressive, the most impressive part of that is the infrastructure, the underlying server, storage, compute, network. They all share the same infrastructure. And now, for the past few years, we've taken the same infrastructure and making it available to industry. Because it looked like the things that we cared about, reliability, availability, is the same thing our enterprises care about. So that's where it's not a Silicon Valley tech anymore. The video that we showed, people in Brazil, an innovator for portal telemedicine, and they have the same infrastructure. The same infrastructure can be available to any developer in Australia, in Sydney, in India. That's what the democratization means. You have access to that. And we have taken care of in terms of security, connectivity, in terms of network. We even build our own chips so that you can focus on innovation and not racking and stacking of servers and infrastructure. That's huge. But you will say, that's great, that's infrastructure, but also HIPAA compliance, security, privacy is super important in the setting of healthcare. Our Google Cloud does provide that. So once you have this infrastructure, you can build a lot of innovation experiences, and these are some of the work our customers are doing, and our partners, patient experience, clinical and operational analytics, caregiver experience, data interoperability, population health, research. Again, same infrastructure available to everyone to build these powerful experiences, just like we did with our products. So that was bullet number 1, democratization of infrastructure. The second is around health data interoperability. It's crucial to have that innovation journey, and interoperability is the heart of the patient centricity. How many folks here have heard of FHIR? Well, one of the Australian gentlemen, Graham Grieve, is a father of FHIR. It's amazing that he sits here and he's having such influence in the US in terms of pushing that standard. In 2017, we worked with him and supported the FHIR Foundation. So think of it as a very JSON-based standard, open standard to access your clinical information via APIs. And why that is important, before joining Google and Apogee, I was at Kaiser Permanente. Let's say I needed my medication that I'm taking. Each time I turned to a developer, there was a different interface or different parameters for what medication is, what is a unit. FHIR provides a common language. That way, if there's a common language, multiple hospitals can use a medication and it means the same thing. That's semantic interoperability. It's super important to speak the same language when you're asking for patient data. These are life critical systems, and not having shared understanding of what clinical records we are calling, the other parts will be super dependent on that semantic interoperability. Our product Cloud Healthcare API, so once you have the semantic interoperability, and I'll give an example of what that API does. So this is a typical health IT landscape. No matter when you're talking to a big hospital, an insurance company, of course the system will differ. So at the bottom, what I call are the system of records. these are the system of records, which is your EMR system, membership system, data warehouse, data analytics, and they've been there, and they are kind of crown jewel for an organization because that's where the data lives. The top layer is the new innovations, the remote monitoring apps, and the patient experience, provider experience that are coming. But the speed at which the lower layer moves is very brittle. It takes months, many months to make a change. So we believe cloud and AI platform somehow sits in between the bottom layer, which is your system of records, and to match the speed of the new innovation that are coming in. And let me ask, why that is important. As you're building new applications, there's an app for everything. It's an app for diabetes, weight loss, nutrition. Any guesses on how many number of apps do we have? In the digital health apps, not just any apps. Numbers? 100. Much higher. The last I checked, 200,000 plus just in the Apple App Store alone. There's an app for everything, I kid you not. Now let me ask, how many of these apps actually connect to your medical record? Any guesses? It's a little higher than 0. It's 2%, right? That's where if you want to build meaningful experiences, they need to be connected. They need to be connected to your medical records, and that's where interoperability becomes very important. But interoperability also becomes important when you're combining multiple different data types. I gave an example of running a query on identifying female age 45 to 60. If I have to do that, so EHR has your medical record, your imaging, and your genomics information is in a completely different data set. That's what we call data silos. And rightfully so. Each system does its job very well. So what we believe, if you talk open standards, so HL7, FHIR for EHR information, DICOM is an industry open standard for imaging, getting PACS images, and then G4GH is the APIs for pulling the genomics information. So industry needs to speak the language of healthcare, and we have done that with Google Cloud. We're teaching our cloud to speak HL7, FHIR, DICOM, so that we can then ingest the data, get it in the cloud, do cross-modality analytics, and then be able to help our customers apply AI and machine learning. More modalities, IoT. How many people here wear wearables? Fitbit. Like that's a new breed of data called patient-generated data. Like how am I walking? What am I eating? All that data is also coming in, and it's a brand new modality. And proud to say that we work very closely with Fitbit in getting that information onto Google Cloud. But again, it's the patient data. We don't have access to it. But if, for example, you're running a campaign around diabetes monitoring, you want to know whether your cohort of diabetic population, if they're given this guideline of walking 3 miles and eating under 1,200 calories, I'm making that number up, it could be up or down, right? That lifestyle, nutrition, activity is very important for when you're managing a chronic condition like diabetes. Now, this new data is new to healthcare. Right, we are very used to medication and electronic medical record, but with the advent of wearables, this information is also key to really providing you guidance and counseling for managing your condition. Like Empower Me. If I'm diabetic, just telling me to lose weight and walk more is not enough. But telling me based on, Aashima, your activity, we see that you skip your breakfast and then go for cupcake at 1 p.m. Right? That's empowerment to me, and telling me targeted advice that this is how you can manage your condition. Now, diabetes is one example, but we can have a very similar cohort for congestive heart failures, high blood pressure. Like, how can you have that type of counseling, knowing my medication history, knowing my genetic history, giving that advice and empowering me to take care of my own health. That is what the patient centricity is, and without interoperability, it will not reach its full potential. So the message here is talking standards, talking open standards is key and crucial to bring the data from multiple different modalities onto the cloud so you can do a patient-centric longitudinal view for the patient. And then, of course, once the data is there, you can apply different analytics, different reporting, population-level reporting, mobile application, what have you. But that secondary data layer, without that, it's very hard to bring that ecosystem around it. So I have some more examples, and now adding NLP, natural language processing, the master patient index, all that will be, again, built on top of that, but the basic layer is to be able to ingest the data so that you can create these serving applications which are patient-centric. As I mentioned, this is one slide that summarizes the other little boxes that I just shared. On the left-hand side are the different data sets that are coming in. In the middle is the cloud environment for you to do your analytics. And on your right-hand side is the application. Most people sometimes focus on the right-hand side on the applications, but to really build a compelling, connected experience for a consumer, you really need the middle layer. So we talked about three themes to democratizing innovation. The first was the infrastructure. The second was interoperability, the topic that I just covered. And now let me shift gears and say what does democratization of machine learning means. So with Google Cloud, we give you the flexibility to use our models, and I'll give you an example of what that is. But also train your own models, right? When you talk about machine learning, how many folks here think that in their organization there's enough machine learning expertise? But that's very reflective of the industry. It's not just here. We hear that a lot. Everyone talks about AI and machine learning, and I have a joke about it that it's not a pixie dust. You're not going to get it. We need skilling, we need the data to build the right machine learning models, but by partnering with the Google Cloud provider or tech provider like Google Cloud, you get those tools, which we are making available to our community to really deep dive into the machine learning side. So let me do a quick run through what the machine learning means in the context of reskilling. So on the left-hand side, we are very used to rules-based programming, like if, then else. Back in college, I studied COBOL as well, and Pascal. I'm very used to this. How many people do if, then else? Right, those are your traditional rule-based programming. You know the rule, and you code it. If this happens, then do that. Machine learning is very different. Machine learning is based on it learns by examples. That's the primary difference. In the rule-based programming, a human gives the rules, and the machine executes according to those rules. In a machine learning environment, the machine learns by examples. You feed them enough examples, and then machine tends to learn, and I'll share what that means. So machine learning task, easy for humans, but not for machines. We all have vision, we recognize objects. I have two daughters, when the younger one you were showing, this is an apple, this is a banana, human learns, they have that vision. That task for a computer is insanely difficult for a computer to see and identify an object. These are the tasks machines so humans are good at. Natural language understanding. We can see whether the tone, if you have an argument or if you have a conversation, we have that sense of what was the intent, what was the tone. It's a human-centric task, and humans are brilliant at it. Machines do not know. But too complex for one human. If I say, can you scan through all your books in the libraries and tell me a reference to a topic, right? That scale is very hard for humans to process a lot of information and make sense of it. So what is deep learning? It is one of the branch of machine learning which has gained popularity immensely since 2012. And what that means at the very, very simple level, you show a computer a picture of a cat, and you run through a network, and computer is able to identify if it's a cat or a dog. This task was nearly impossible. Like, artificial intelligence has been there for many decades, but not till 2012 that the deep learning methods proved that it's possible for a computer to identify vision, identify objects like a cat or a dog. It's a simple thing, but it's insanely difficult. So this is a branch called supervised learning by example. So we show a computer a lot of images, like millions of images of a cat, and the computer learns and say, okay, when you give it a new image of a cat, it's able to say whether it's a cat or a dog. And it all dates back to the recent excitement around computer vision, goes back to a competition called ImageNet. Have folks heard of it? So it was in Stanford in 2012. What they've done is they have annotated photographs, and photographs of cats, dogs, ships, chairs, you name it. And they're annotated, and they invite industry leaders, researchers to build an algorithm to say whether their algorithm is able to recognize the object or not. So in this picture, can you say if it's a cat or a dog? So the neural network here, it takes the input layer. These are kind of mathematical set of functions. These are neural networks. You give it an image, it goes, and then it is able to recognize as it passes through the layer, if that image, it breaks down the image in multiple pixels and say it's an eye, or that's a very basic premise of a computer vision. So it takes an image, splits it across in multiple tiny pixels, and able to recognize, oh, I saw an eye, or I saw a nose, or an ear. It recognizes a cat or a dog. It takes a lot of training. But importantly, it takes a lot of annotated data. For machine to learn, you really need to have the picture and a human telling what that is, and you give them enough examples, and you train your model, and the model is then able to determine the object. As I mentioned, the 2012, a researcher from University of Toronto created the neural network that actually surpassed, at that point, the human, the vision, meaning they were given this challenges, they're given a set of objects, and the algorithm has to determine what is that object. Not just that they are able to see the object, they can also do the classification, like similar, what kind of a flower this is. It can also say, like generalization, if it's a meal. So enough annotations, enough photographs, and then the model is able to learn. That's what, at a very simplistic level, is deep learning. Now you say, Aashima, that's great. What's the relevance for healthcare? So what are some ways deep learning is having a significant impact in healthcare? So when you look into the machine vision tasks, it's able to classify not just that it's a flower, but that it's a specific type of a flower. It's able to localize. If they've seen this is all computer results, it's able to say, oh, I see a bus. And summarization, based on a picture, a computer is able to tell a group of young people playing a game of frisbees. Now, in the healthcare setting, when you say classification, you're able to say it's a benign or a malignant tumor. Or localization, where is the cancer? What is the contouring around that? And summarization. But to do these either classification, localization, or summarization, the data, the labeling is very important. In this case, we have shown, in this example, for it to come to life, you have to show them enough benign and malignant tumors. You work with the pathology labs or imaging, and you give examples of annotation, and they need to be right, that this image is benign, and then after the more data we have, the better your vision model would be. And then it'll be able to identify, given a new image that it has not seen before, it'll be able to tell the classification of the. So where ML can have a big impact is where the expertise is limited, lots of data, lots of annotated data for supervised learning, and predictions are actionable. So I'll give you a real example of how Google has built a model on diabetic retinopathy by using the same computer vision technique. So 415 million people with diabetes worldwide. And people who have diabetes are at the risk of diabetic retinopathy disease. It's a degeneration of the image retinas fundus, and you can actually see if you take the picture at the back of your retina, and I'll show you just in a bit. So when we're talking about this condition about diabetic retinopathy, it's a leading cause of blindness. In India alone, 45% patients suffer vision loss before diagnosis. How the disease is diagnosed, if you look into the healthy retina and the disease, you're seeing a little capillaries or little bursts there. So the two images look different. On the left-hand side, or the healthy one, there's no broken capillaries. And on the right-hand side, there's some hemorrhages. So we took 130,000 images, worked with 54 ophthalmologists to really to annotate. And if you're like me and have gone to multiple doctors and you say it's very hard for them to agree on a single thing, but we were able to get them to really come together and annotate, okay, what do you think of this disease? And there's different levels: no DR, mild, moderate, severe, and really the red is the highest it can go. So here the important part was you worked and partnered with ophthalmologists, got the labels done, and then we fed it. The Google's engineers were very curious. Can it now, if I give a brand new image of a new retina, would it be able to detect, A, whether it has a disease, or if it has a disease, what is the level of progression? It was a 26 layers deep learning network. The work is not yet done, but the results were very promising and encouraging. What the algorithm was able to share with a lot of training and the input of those 58 plus ophthalmologists, we have F-score of 0.95, and ophthalmologist median was 0.91. But the work is still not done, right? This has to now go back to the clinical workflow so we are working with our Urban Eye Hospital in India, where this algorithm, we take a picture. So the point here is not you build an algorithm, that's AI innovation has to come into the clinical setting, and we're working with clinicians there, and with the shortage of eye doctors, the first check is done by this algorithm, and then if they say, oh yes, then it is referred then to a specialist. Again, this is one example. I hope that inspires many such examples where we have high fidelity images, rightly annotated, and then leveraging computer vision, can we help our doctors? Can we assist them? And we also actually this work was published in JAMA I think a year and a half ago. It's up to peer review, so we share all this research. There's also new research that's coming out that an algorithm and a doctor actually are a better predictor than by just the algorithm or a doctor alone. So we believe there's a whole concept of assisting your physician, giving them this tool will lead to better diagnosis than just an algo alone, just a physician alone. So these are the tools that we can make available to ophthalmologist to help make the diagnosis. As I mentioned, we are working with the Urban Eye Hospital. This is now in a limited pilot there, and we'll continue to build on it, learn from it, and see where more we can do in terms of this computer vision. A few months ago, a lung cancer research came out from Google as well from my colleagues, where they were able to, again, use computer vision to see the nodules and identify the CT scan, and the algorithm is able to predict whether the person has a lung cancer or not. But the same collaboration. DeepMind, just last week, have acute kidney injury. Similarly, a machine learning model where they're able to detect the acute kidney injury 48 hours or so in advance. This was published in Nature. So more work is going on in terms of building this model, learning. These are still early days. So by no means I will tell you that this is ready for prime time, but the inspiring work is continuing on. These are not just ideas, but concrete pilots that are now in the field, and we are learning from them. So now you'll say, okay, great, Aashima, that's Google. You have researchers and access, and you're able to do this level of AI machine learning. What about the industry? Very few users today can create a custom machine learning model. And we believe the 3 pillars that I talked about, democratization of infrastructure, democratization of interoperability or patient records, and the 3rd pillar is very close to us, is democratization of artificial intelligence, and to make AI accessible to millions more. So we have rolled out this new technology called AutoML. It's a little spooky if you think it's an algorithm that can create a machine learning model. It learns from your images, and you can give that to your teams and leverage this tool to build machine learning model. If you look, I'll show you an example of how that works. It's a UI, you build the images, but again, what it will not do is take your data, make sure it's clean, make sure it's labeled right. That part still belongs to you. So if you have the images, you annotated it right, for computer vision, technologies like Cloud AutoML can help create the machine learning model for your teams. So same thing, the principle is the same. You give them enough images. In this case, example is a handbag, shoe, or a hat, or a retinal fundus image, or a CT for lung, or what have you. The principle is the same. You take the label images, you label them right, you train your model, and then you evaluate. These are the 3-step process, and we give you the tools where you can actually upload the image, have the annotate label, and out comes the pre-built machine learning model that you can leverage and test. Why we thought it was important? Because for machine learning and AI to really benefit the society and healthcare, it needs to be done by ecosystem. It needs to be done by everyone, not just one company and not just by few select PhDs or developers. That's why democratization is important, because it needs industry and participation. So those were the principles and how the Cloud AutoML was launched. I played with it. This was a demo that I had built for a dermatology clinic. And I was joking, the hardest part for me was collecting those 2,000 images of rashes and kind of going to the label. It was pretty icky. But once I had the images, this is the UI, which is the actual product. And training takes anywhere between 10 minutes to 24 hours. And depends upon that, if you have more images, it'll take more time. And it's able to do the predictions based on when you give it a new image or a new rash, it'll be able to say whether it's a poison ivy or it's eczema. And we worked with a dermatology clinic. Again, this was done for a demo. This was not a research as the diabetic retinopathy. So this was the type of images we were able to get from the clinic, label them, and the AutoML, created a model, and then I gave it a new rash, and was able to predict what kind of a rash or skin disease that is. So in summary, when we're thinking about democratization of AI and machine learning, it's about giving tools to the industry, it's about giving tools to the developers to help build new stuff. And we are continuously adding to that from the cloud perspective, very enterprise focused, and looking for partnerships, solutions to really bring them to life with the entire ecosystem. So that's all I had. Thank you.